But when the power's out, there's no water. So we're real excited about getting this going.
Zach, go to church with Bob. Happy to help. I'm Alex, same.
Tommy, same.
Jacob, same, and I'm a brand new HVAC tech.
Okay.
Nick.
I'm Carla. We know nothing about this.
Okay.
I'm David. Along with these guys, go to church with Bob.
Okay.
And that's Andrew.
And we know Andrew. I'm Shawn. I do off-grid solar designs, and occasionally I'll do a workshop like this where we do a small install. That way I can kind of answer people's questions. I'm not an electrical contractor. I am someone that helps people that want to go off-grid or take systems like this. So what we're doing today, Bob has an existing circuit that is powering his well pump, okay? And so what we're doing is we're putting an inverter in line with that existing circuit with solar and a lithium iron phosphate battery, okay? And so what that's going to do is it's going to allow him to program this inverter to, let's just say, keep the battery at 100% at all times, use the solar power when it's available to power the pump, and then use utility at all other times. Or he might say, take the battery down to 50% and then charge it back up with solar only. Like, there's all kinds of things he can do there.
That was kind of my thought.
Yeah, the primary reason for putting the system in, as Bob just mentioned, is he wants to be able to get water out of this resource that he has down here if the power's out, right? That's the main reasoning for it. And so with this system, we're going to have a small, it's relatively small. It's about 5,000 watt hours, okay? And so it's just one big battery pack. It's about 100 pounds, the one battery. It's a 48 volt battery, okay? And so we don't know exactly what Bob's pump pulls when it's on. Once we get the system set up, we'll figure that out. And then that'll give him a good idea of kind of how long he can run that pump with a full battery. Then we can also take the panels that are going in and figure out generally how much solar power he's going to be able to generate in a day. And I think what we'll probably find is he'll have way more power than he needs for just the pump. And so eventually he'll probably be walking around looking for other things to do with this free solar power that's coming in. Because the great thing about solar is once you've got the system in, it just, works. Like the sun comes out and you don't have to do anything. There's no fuel input costs after that. So what we have here are 4 Hyundai, just like the car company, 395 watt panels. These are bifacial, which means they have glass on the front and the back, which means that if they were mounted in a way where light could bounce off the ground and hit the back, they could actually generate up to 25%. The reality is, in our part of the world, that's like 5%, but it's more than zero. However, these panels are going to be going up on the roof, so they won't have any bifacial gain.
Yeah.
Now, a couple of things to go ahead.
So these panels, like I told you, I wanted mine at an angle. These would be the type of panels I would use.
Sure. Yeah, there's actually places where they take these panels and they'll build fences with them. And they'll take the front of the panels on one side of the fence and face them east, and the other side and face them west. And those panels don't create exactly the amount of energy that they would if they were pointed due south and at the perfect angle, but it's close. It's kind of amazing how much these panels can, just like vertically. The reason why we are using bifacial panels today is up until like right now, these were exempt from the solar panel tariffs that were put in several years ago. So bifacial panels were exempt, and so price per watt, these have been the cheapest panels you can get for a couple of years now.
And how much are those?
So these panels right here are 120 bucks. So they work out to about 30 cents a watt. Okay. Last year, I was like, when the prices went down to like 35 cents a watt, I was telling people, buy panels. You've never seen prices this low before. And then, like, literally for the next 6 months in a row, the prices went down, 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 down. They're on the upswing now because all of the tariff exempt panels are getting sucked up from the warehouses, and also because there's kind of like this fear of missing out thing going on. People are buying them even though they don't necessarily need them, and so guys that are sitting on megawatts in warehouses are saying, well, look, we can charge 40 cents a watt. People are going to pay it, so why sell them for 28? You know.
Right.
But there's still panels there. So there's a place in Sparta, Tennessee, that is they buy like whole solar fields and then they refurbish those panels at their place and test them. And most of these panels will actually test at or above with their nameplate rating. So what I'm saying is a 300 watt panel is testing at or above 300 watts. Okay. And so if you're looking to do a system and you want to do it the most cost-effective way possible, buying used panels that have been refurbished and tested is typically the best way to do that. These kind of just, I grabbed them when there was a really good deal going on. The thing to remember if you're going to do a solar system is the federal government will give you 30% tax credit for the entire cost of your system. But from a panel, let me rephrase, but it only applies to new gear.
Oh, okay.
Okay, so if you buy used panels and new inverter, battery, etc., you can still get the tax credit for all the rest of the stuff, just
Okay.
not the new panels, because
Okay.
theoretically someone else has already taken
Right.
the tax credit for those panels. Because if you ever see those big solar fields, like it's just a big tax credit harvesting, scheme. Like
Okay.
they'll buy the land, they'll put all these solar panels in there. They'll get their 30% tax credit. They'll depreciate it out over 5 years. They'll sell all the power that's generated to TVA, for example. And then after 5 years, it's depreciated to zero value. They will sell those panels to a third-party company, put new panels on, get the tax credit again, depreciate it out over 5 years, and boom, boom, boom. So we are at the tail end of one of those 5-year boom cycles.
Okay.
And so in about 3 years, you're going to see another flood of used panels
Okay.
hitting the market. And like right now, I was telling Bob maybe a month or two ago, he's actually got panels for like 11 cents a watt there. Now you got to buy them by the pallet, because like that's how they do it. They'll literally buy truckloads. They'll test them and palletize them as they're testing them. So you have to buy them by the pallet in order to get those deals. But I'm through there enough to where I'll like grab a pallet and then sell those off to people and stuff
Okay.
like that. So, but I can pass that contact information along if you guys are interested in doing that. Any questions?
So how much of the capacity of this system do you think he's going to be using for just a well pump?
Very little. We don't know. We won't know until we actually hook it up. But I would guess that pump is probably pulling 600 watt hours a day, is my guess. Something like that. Very, very minimal.
Yeah, it would typically probably only run for 10 or 15 minutes. So
Yeah, the size of this inverter and battery is more about the surge than it is about the throughput.
have you ever messed with the soft start circuit?
Yep. I've put them on AC units before.
And do they do what they're advertised to do?
Oh yeah. Yeah, they'll take a 3-ton AC unit that's got 170 amp locked rotor amperage, and you won't see anything more than 40 on it. And 40 for like just a little bit of time.
Right.
It totally works.
Now this has to be out, right? You can't have it. Okay, so the fans are there.
Okay, we'll just tighten that down.
Okay.
And in the middle, same thing, it slides into the channel, but now, have to loosen a little bit, but it'll grab that panel and then the panel on the other side.
Cool.
Okay.
Okay.
All right.
So are these going vertically on the roof or horizontally on the roof?
Yes. The long direction of the panel will be running towards the
So it'll
peak.
be in portrait.
Yep.
Ah, portrait.
Yep. Single high portrait 4 wide.
So like
Single
this,
portrait forward. Okay.
not like this.
I'm okay with that.
This would have to be put in here. You have that. I got this gas. Pretty much, I think.
Now, what was 48?
How you want to do this?
Get that filter out of there first. I mean, I'm gonna need help with all the electric.
Right, right.
Just throw it over there,
You sit down, and I'll push it up as high as I can, and then you can come in, hit that screw. I'll hit the bottom one, and then we'll put some more screws in. Okay.
I don't know.
You better come down then.
Yeah, I think he went up to that first shingle.
Okay, we're considering where the battery's gonna go, right?
Well, I mean, we've got what space we have, and then we'll figure out where the battery's going to go.
Because I was thinking it would go side by side.
No, they won't fit side by side.
Really? Yeah.
I think if we get this all the way up,
It might go
it'll
under.
go underneath.
Okay.
Yeah.
So you're gonna be able to.
I can lift it up. You think you're going to be able to get?
I think so. I'll do my best as fast as I can. No. We're gonna have to do the bottom first.
Did that excavator guy ever do what he was supposed to do?
Underneath it for the battery or not?
You were going to hire me, or I was going to show you how to use a skid steer with a rock hammer to break up.
That thing 100 pounds.
Yeah, a little over 50, I think.
Ish. So if you can get it up, I can get my hand under it and hold it, and you can. Or if you take this, then I can use 2 hands.
Yeah, I was going to do it with the same price he was. I just don't have the equipment.
Has it got it? You might want to put a lag bolt in there as well.
So to get that other screw, you're gonna have to come in, yeah, that way.
We're doing one wire at a time, and what I always do is I start with the ground wire, because the very first thing I want to do is to make the system safe to work on. So I'm starting with the ground wire. I'm just using a split bolt to run, and I'm running a 6-gauge wire because that's what I have. This is way too big for what I actually need, but we don't need to get into that calculation. I'm marking it green so that I know that it's ground, and so that anyone that comes after me can look at it and visually see that it's ground. When we run the neutral, I'll do the same thing. It's going to be a black wire. I will put white tape on it. When we run line 1, I'll put red tape on it, and I will actually put black tape on the black one as well, just so everyone that comes behind me knows each one of these wires is a certain thing. When we go into the inverter, the other end of those wires will be marked the same way, which is why I do them one at a time. I do green, I go inside and do green. I come out and do white, I go inside and do white, then I do red, then I do black. And so it just makes sure that I don't end up accidentally crossing wires. On this short of a run, it's not that big of a deal, but if I was pulling wire a couple 100 feet, I would definitely want to make sure that it was marked before I started pulling it. I don't want to get to the other end and then have to run continuity test to figure out which wire is which. So this is the inverter. I've got the cover off. I've got 2 terminals here, battery plus, battery negative. These are where my thick battery cables will be connected. Then I've got my load terminal. This is where the 2 hot legs will go out for the actual load, or the panel, if I was running a panel. Then I've got 2 hots for the grid. So when I bring the AC input in, they'll go here. And if I had a generator, I've got the 2 hot legs for the generator as well. Then I've got a neutral bus bar, and I've got a ground bus bar. So right now, as I just mentioned, I've got my ground marked already. So I'm just going to run this up and in to the ground bus. And then my ground is complete, and then the system is safer for me to work on. So there's no power in here right now. You know, I've got my voltage pin. I can come in and I haven't hooked anything up, so I know there's no power, but I still want to always hook my ground up first.
Maybe. But then again, it's checking in my parents' house, so I'd have to convince them.
Do it.
So these are the wires from the panel, and that is a DC disconnect?
Yes. Correct on both accounts. What we're doing is
What do you need?
Stubby.
there is a disconnect on the side of the inverter, but since the inverter is in an enclosure and the disconnect is not readily accessible, we're putting one on the outside here too. You always want to be able to isolate all of your inputs from the system individually, and so that's what this is going to be able. That's what this is going to allow us to do.
I'm not sure. I think my parents got it specifically as a retirement home.
So I see several disconnects here.
They may eventually
What's going on with that?
move down.
So
Retire.
the one right in front of my hand is the solar disconnect. This one here is the AC input disconnect.
14 or 16, but I'm pretty sure they're still in the 50s.
The AC output disconnect is on the inverter.
It would have been a big acceleration.
And then this is the switch that turns on the power to the pump. So this is essentially the switch for the pump. So it's kind of like an AC output disconnect, but just for that circuit.
So you just measured 167 volts from the panels at this box?
Mm-hmm.
And how does that change based on how you wire the panels or how many panels or?
So when you wire panels together in series, which is positive to negative and positive to negative, you increase the voltage. So if I took two panels that had 44 volts and wired them together positive to negative, and then I grabbed the open positive from the one panel and the open negative from the other panel, I would have 88 volts. Okay? If I wire positive to positive and negative to negative, that's parallel. And in a parallel connection, you, instead of adding voltage, you add current or amps. And so in this specific setup, we are 4 panels wired together in series. So we would have the equivalent of 4 times the voltage and 1 times the amperage. If everything was wired in parallel, it'd be the other way. Hey, the connection between the battery and the inverter. We're gonna, the battery's still off, okay? The reason why we do that is when the battery comes on, it actually has a function where it's kind of testing, and it will slowly charge up the capacitors in your inverter, okay? So just make sure the power, yep, okay. So the first is this black one here. All right. Yeah. So all that does is now we're connected from the battery to the inverter.
Okay.
Okay. Now when I flip the battery switch on, it's going to go through its startup phase, and then run. More on. There we go. Okay. So you saw how the lights were going blink, 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 blink. Mm-hmm. That was charging up the capacitors. That's like its startup phase. Okay. If you had multiple batteries, you would wait for this battery to start blinking run before you turn the next one on for that exact same reason, so that you don't get a voltage surge or current surge. So now we're going to turn the PV on. Now that we've done that, you shouldn't have to mess with that one again. Okay, so now our PV's on. So now we're going to close our external breaker between the panel and the inverter, and then the grid breaker on the front of the unit, which is the middle one. Okay. So now we have battery power to the inverter, solar power to the inverter, grid power to the inverter. So all of our inputs are now on, okay? So now we're going to power on the inverter, which is a switch on the other side. And it should take a second to go through its startup. And then once it's done, once it's basically gone through its startup, then we can turn the EPS, which is external power source, EPS output on, and then flip the output breaker. So we'll give it a second. So actually this, let's see, yes, this first. I am going to double check that we're getting the right voltage there as well before I flip the EPS on. Not get the right, oh, I guess I'm not going to get the right voltage until I turn this on, so.
I heard a relay.
Uh-huh. So
Do I?
now,
I heard a relay.
now I should be getting, yeah, not 240, but close enough.
237.
Yeah. So right now we are inverting, and we've got 1,130 watts going to the pump, which means your pump's on. So your pump right now is running off the inverter.
Wow, that's awesome. And it was 1,000 watts?
1130. I didn't see the surge,
Yeah.
but yeah. And it's 0 now.
So it's off.
Yeah. So now we're going to hook the Wi-Fi up. I assume you want the app and all that so you can monitor it remotely.
Yeah.
And then I'm going to turn it all off and program it. But it doesn't have to be programmed with all that stuff in order for us to do the initial startup test. Like I haven't even connected the comms between the battery yet.
And what is the programming about?
So the programming is going to do a couple different things. It's going to allow us to tell the inverter how to treat the battery. So that might mean take the battery down to 50% and then charge it back up, or keep it at 100, or whatever Bob wants to do in terms of battery use. Okay. We can tell it how to prioritize its inputs. So we can tell it